Hey guys, today we are talking about A, H, and K again. Remember for 13.1 we talked about this kind of equation for logarithm functions and log, natural log, stuff like that. But today we're talking about exponential, the inverse of those logarithm functions. And an exponential function really just works in the sense that my H is just hiding up here. You can kind of think about there being like little parentheses right there for my x minus h there, or whatever, but that's, my h is still with the x, it's just inside the exponent, okay? So instead of being like in the parentheses of the logarithm, it's just inside the exponent. And it kind of works a similar way, okay? And we're not really going to be graphing today, just like we did for 13.1. What we're really going to be doing is we're going to be focusing on writing the equation, finding your x and y intercepts, and we'll be graphing tomorrow, okay? So let's start here talking about, remember, vertical stretch and compress is A, vertical reflection, that's A, horizontal shift, your left and right shift, that is H, and H is a liar, okay? And our vertical shift, remember, that's our up and down, that is our K, all right? So you should remember all that at least a little bit. Let's take a look here at number 1. So number 1, we start with our f of x, and we're going to be writing in our g of x. So we have f of x equals 2 to the power of x. Okay, so this base is just our starting point. It doesn't really affect a whole lot, okay? It's not going to affect any of your transformations. We're still going to be looking at a, h, and k. Your a is still going to be the number out in front. So think about this kind of like as your logarithm, as your just parentheses, as your number, okay? And so here, f of x here, it says vertical stretch by a factor of 6. So here's the deal, vertical stretch, remember A controls your vertical stretch or compress, okay? So A controls our vertical stretch and compress. So on this one, if I have a vertical stretch by a factor of 6, that means that A equals 6, okay? And then it says translated 5 units down. Now, my up and down is controlled by my K. So, my up and down, that means if we're going to go down, that means I'm going to have my K is going to be -5. So, nothing else is here, so we can write out my equation. So start off, we're going to write g of x. We're just changing my f of x to g of x. We're just showing that it's a new function that we've added on to. So we're going to go g of x equals, now my a is 6, so it still goes out in front. And I have 6 times 2 to the x. Now, I don't have an h that needs to go inside with that x, so we just leave it as 2 to the x. So we have 6 times 2 to the x, and then we are going to have this -5 here on the end. Okay? All right, let's take a look at number 2. So number 2, we start with a base of 10. Nothing changes there. Okay? Then we have a reflection vertically. Okay? So that means that we're going to have a negative a. So a negative out in front. If it doesn't give you what your a is, we're just going to have a negative in front. A -1, you might say. All right? So that's another thing. That a also does our reflections. All right? So that's something to keep in mind. Okay. Followed by a translation 9 units down. So remember, that's our k. So my k is going to equal -9. Now I can just write my equation. I can go f of x equals -10 to the power of x minus 9 there on the end. I wrote f of x. It doesn't really matter, but I do want to be specific and say that this should be g of x because we're writing a new equation. All right, take a look at number 3. And number 4 with me, please. So number 3, we have translated 2 units up, followed by a reflection vertically. So our base is E this time. Base does not matter, okay? So translation 2 units up. So once again, that's going to be my K. We're going to go K equals 2. And we're going to have a vertical reflection. Love it. So that's going to be a -a. I don't know why I wrote that like a 9. It should just be really long tail. All right, so -a. All right, so we can just write our equation. We're going to go g of x equals -1 e to the x plus 2. All right, our last one here, number 4. So number 4, we have 2 to the x. So my base is 2. We have a translation 3 units to the left. Okay, so this is the first time that we have seen a k value. My k is going to be negative 3. All right, because remember, sorry, not my k, my h. My h is our left and right, and it is also a line. Okay, so let me fix this. I messed up. So this is my h. So my h is going to be negative 3. Now it's negative 3 because we're going to the left 3. But when I plug it into my equation, remember it's a liar, so when it goes to my equation, it's going to be a plus 3. All right, so then we're going to have 1 unit up. So we're going to go k equals 1, followed by a vertical shrink by a factor of 1/2. So vertical shrink by a factor of 1/2, that means my a is 1/2. Remember, vertical shrink, compress, stretch, all of that is talking about my a value. So we can write out our equation. We go g of x equals 1/2 times my base is 2 to the x plus 3. Notice how I made that a positive there whenever I plugged it into my equation. And then we're going to have a plus 1 here on the end. Okay? And there is our equation for this one. All right, let's turn the page. And let's take a look at our last two here, 5 and 6. Number 5, it says, we have a horizontal asymptote at y equals negative 3. Now, remember, when we did 13.1, we had vertical asymptotes, and those vertical asymptotes were connected to my h value. Well, now I have these horizontal asymptotes, and this horizontal asymptote is going to be connected to my y value, and so that's going to be my k as well. So whenever you see a horizontal asymptote, that is your k value. So my k is going to be negative 3 as well. All right, because think about it, it's the inverse of a logarithm, and so that horizontal asymptote is going to be created, and whenever I move that horizontal asymptote up and down, it creates my k value. So my k equals negative 3 on this one, followed by a vertical stretch by a factor of 4. That just means that I have my a equals 4. So we can write this out. G of x equals 4 times my base is 10 to the power of x, and then a minus 3 here. Okay? Remember, if it's up in the exponent, if it's inside the exponent, it's your h. If it's on the outside down here, it is your k. All right, so there we go. Number 6, we have f of x equals e to the x, given h equals 4, k equals negative 2, and a equals 1/2. Too easy. We're just going to write g of x equals my a first, so we have 1/2 times e to the x minus 4 for my h whenever I plug that in. Okay, that means we're going to go to the right 4, but we have to have a minus 4 on the inside here. And then we're going to have a minus 2 on the end outside of my exponent. All right, well that is just how we that's how we write the equations for these. Pretty straightforward. All right, let's take a look at these down here. On these, this is just like what we did for 13.1, except we have exponentials. We're going to find the x-intercept and the y-intercept. Remember, to find the x-intercept, you make y 0. To find your y-intercept, you make x 0. So we're going to always start with the y-intercept because it's easier. So for my y-intercept, I'm going to plug in 0 for x in this equation. So I'm going to go y equals 2 times 0 minus 3 plus 1. So 0 minus 3 is negative 3. All right, 2 to the negative 3. We can plug that into my calculator. 2 to the negative 3 is 0.125. So we're going to have 0.125 plus 1 is 1.125. Okay, and that is going to be what my y value equals on this one. So my y-intercept is going to be at 0, 1.125. All right, what about my x-intercept? Okay, so for my x-intercept, remember what we do. We're going to make my y 0. So we're going to go 0 equals 2 times x minus 3 plus 1. And now we're just going to be solving this, okay? So we're just going to be solving for my x. All right, so to do that, we're going to need to minus 1 to both sides. That's going to give me negative 1 equals 2 to the x minus 3. Now, how do I get rid of that base. How do I get rid of that base of 2? Well, we have to rewrite it as a logarithm. So I'm going to go log base 2 of -1 equals x minus 3. So we go log base 2 of -1 equals x minus 3. Okay, so now I can plug that into my calculator and get an answer for it. Okay, we can write log of -1 divided by log of 2, right? And then I can just add 3 to both sides and get my x value. So let's do that. Let's plug this in. Let's go log of -1 divided by log of 3. Hit enter. Oh man, we get an error, non-real answers. Let's see why that happened. Non-real answers, oh, well, look at this. That log of -1, we cannot take the log of a negative. So, what's my answer going to be? There is no answer. So there's no solution to this one. So, what's my x-intercept? There isn't one. It is none. Okay? So, remember, cannot take the log of a negative. Let's take a look at number 8. So number 8, we're going to be doing something similar. So first off, let's find my y-intercept. To do that, let's plug in 0 for x. So we're going to go -2 times 10 to the 0 plus 1 minus 3. So 10 to the 1 is 10. So we're going to have -2 times 10 minus 3. -2 times 10 is -20. -20 minus 3 is -23. So that's what y is going to equal. So we're going to have a y-intercept at 0, -23. Okay, now for our x-intercept, we're going to do the same thing as what we've been doing, right? We're going to go block this off, and we can plug in 0 for y. So I can go 0 equals -2 times 10 to the x plus 1 minus 3. So let's start off here. Let us add 3 to both sides. Get 3 equals -2 times 10 to the x plus 1. Then I can divide both sides by -2. Divide both sides by -2. And then we're going to get -3/2 equals 10 to the x plus 1. I can rewrite this as a logarithm now and go log base 10 of, so we're going to go log base 10, which I can just write log of -3/2 equals x plus 1. So remember, this logarithm here, this logarithm of that negative, we don't have to write the base for because my base is just 10. Secondly, we're taking the log of a negative again. We cannot take the log of a negative or 0. So this one's not going to work out. This one is going to be no solution again. So we are not going to have an x-intercept. Now, this will make more sense of why we don't have an x-intercept is because we have that vertical asymptote. If that vertical asymptote is above my x-axis, sorry, we cannot have a x-intercept. Okay? So, fortunately, it kind of works out like that. All right. Now, let's take a look at 9 and 10. So number 9, same thing. Here we go. We're going to plug in 0 for x to find my y. So we're going to go y equals 1/2 times e to the 0 minus 5. Now listen, anything to the 0th power, even e, anything to the 0th power is 1. So really what we're saying is this is 1/2 times 1 minus 5. So 1/2 times 1 is 1/2. 1/2 minus 5 is -4 and 1/2, or -4.5. So that's my y-intercept at 0 and -4.5. Now for my x-intercept. So for my x-intercept, we're going to plug in 0 for y. Okay, and on this one, I can add 5 to both sides. Get 0 equals 1/2 e to the x. Get rid of that fraction by multiplying both sides by the denominator. Okay. Oh, I didn't change that. I left that a 0 for some reason. Sorry, that should 0 plus 5 is of course 5. Okay, so 2 times 5 is 10. These cancel, and so we get 10 equals e to the x. Now we can rewrite this as a logarithm, but remember, anything with a logarithm with a base of e is natural log. So we're going to go natural log of 10 equals x. So it's going to be natural log of 10 equals x, and I can plug that into my calculator. A little too easy, just natural log of 10, oops, clear, clear, clear. Natural log of 10, don't freeze on me, don't do that. Well, I might have to grab my personal calculator to finish this off here, but you get the idea. We're going to go natural log of 10. So natural log of 10, and that equals 2.303. Okay, so 2.303 is what x equals. So we're going to have an x-intercept at 2.303, comma 0. You could also just write this as the natural log of 10, comma 0. Either way, correct answer. All right, last one here, number 10. Start off, plug 0 in for x. So y equals 10 times 0 minus 3 minus 4. We get 10 to the negative 3 minus 4. 10 to the negative 3. Is going to be 0.001 minus 4. Okay? And so that's just going to give me 0.001 minus 4 is going to give me negative 3.999. So that's what my y-intercept is, negative 3.999. We come down here and we can write this in here. So I can get my y-intercept is going to be 0, negative 3.999. All right, now for my x-intercept, we're going to plug in 0 for y. So we're going to come back up here, plug in 0 for y. So we're going to go 0 equals 10 to the x minus 3 minus 4. Add 4 to both sides. We get 4 equals 10 to the x minus 3. Rewrite this as a logarithm. Log base 10 of 4 equals x minus 3. So log base 10. We don't have to write the base 10, right? So just log of 4 equals x minus 3. Plug that into my calculator. Go log of 4. It gets me 0.6020 and so forth. Add 3 to both sides. And we're going to get x. We're going to get x equals 3.602. And that's going to be my x-intercept, 3.602, comma 0. All right, so there you go. We've got our x-intercepts, we've got our y-intercepts. Everything has worked out. All right, let me know if you have any questions about these. You can also refer back to the 13.1 video to help you kind of understand this a little bit better. All right, thanks, guys. Have a great rest of your day.